Hey, Calc students, more FRQs, free responses from old AP exams. Today we're looking at question number 6 from the test from year 2018 on the AB exam. And right away what's jumping out at you is you have a slope field here, so pretty good likelihood this will be a differential equation question, and it is. So let's see what we have. It says, consider the differential equation dy dx is equal to 1/3 times x times the quantity y minus 2 the quantity squared. Now, whenever you get a differential equation, there's a good chance you're going to have to solve it, but sometimes they do give you differential equations that are not solvable at this level. Well, this one you can probably see if you tried to separate your variables, you could get your variables together, and later on in the question you will need to solve it. But the biggest issue is, are you remembering that the differential equation here is also a derivative? It's also the formula for the slope of the tangent. It's all the same thing. And the relationship of the differential equation to the slope field is that the slope field was generated by using this as your formula. So every little short tangent or baby tangent here, the way the slope was generated was by substituting the coordinate into here. And you can always double check that if you'd like, pick a couple spots. So if you notice, what should jump out on you in the slope field is that the slope of every single tangent all along the y-axis, if you notice, the slope is 0. Well, and so what that's going to tell me is that when x is 0, the slope of the tangent is 0. Well, if you'll notice, let's go ahead and put in any coordinate you want. I don't care what your y value is, but x is 0, y is anything you want. Let's put it into the formula. Well, if you do that, you're going to get 1/3 times 0 times I don't care what y is. It's going to get multiplied by 0. Well, you're going to get 0. And that's why the slope field has a slope of 0 at every single location along the y-axis. Now, it also gives you that, if you'll notice, look at y equals 2. So when y is equal to 2, I don't care what x is. 1/3, I don't care what x is, but 2 minus 2 squared, well, that part's going to give you 0, and this will be 0. So there's two places where the slope of your tangent is 0 the whole time. It's when x is equal to 0, or when y is equal to 2. Just something to notice. You can always just sort of double check some things. So what this is asking us to do, though, is the slope field is given, and sometimes you have to generate it, sometimes it's given and you have to read it. Well, this is the style where they give it to you, and the question is really, do you know how to read a slope field? So it says, sketch the solution curve that passes through the point 0,2, sketch the solution curve that passes through the point 1,0. So there's two separate ones to do. Well, the first one is probably the easiest I've ever seen on an AP exam, to sketch the solution that goes through 2,0, or 0,2. If you'll notice, we were just using that coordinate. Well, the slopes of the tangents are 0 the whole time, so the solution is a horizontal line going through there. That's about as easy to read as possible. And each tangent tells you what to do to get to the next tangent. Well, they were all horizontal. That's about as easy as it gets. Now, looking at the next one, it has to go through the point 1,0. So we're going to have to read this both directions. So at 1,0, they highlight this little point here. As we move to the right, we're just going to allow the tangent to tell us what to do. So as we move to the right, I'm going up. And this tangent is telling me to continue to go up. And the next tangent over is telling me to start to flatten out. And the next tangent is telling me to start to flatten out. So it looks like I'm increasing and then flattening. I'm just reading what each tangent is telling me to do. So from going to the left now, this tells me to go down to here. And this tangent is telling me to continue to go down. And then it looks like I'm needing to, I have a vertex of sorts that's going to have to occur here. Now, as long as you're within range, here you're fine. And so you might think, well, I don't know, do I need to go all the way down to here? Or can I start to flatten out? As long as you're within reason, they're forgiving of exactly where you need to be. And now as we continue upward, you let each subsequent tangent just tell you where to go, and you get this kind of behavior. Okay? So it looks like we've got, kind of almost looks like a quadratic with a horizontal asymptote. So a little bit strange there. It could even, it almost looks like it could be sinusoidal, but this horizontal asymptote is interesting. And we have the equation right here, so it's not sinusoidal, but we definitely have some interesting behavior here. So that's the first question. Can you just read a slope field? And so all you do is you allow the tangents at each x value to influence you going up or down at the rate at which the tangent is showing. So as long as you can connect the baby tangents at close to the same influence of each one, you're going to be fine. So there it is. So A was demonstrated there. Let's move on to B. B says, let f of x be a particular solution to the given differential equation with the initial condition 1, 0. So they're telling us we have this coordinate 1, 0, or if you prefer, f of 1 is equal to 0. Write an equation for the line tangent to the graph at that location, and then use it to approximate f of 0.7. Okay, well this is a very common question. Write the equation of the tangent at that coordinate. So we're going to do y equals mx plus b, or, for you point slope people, y minus y sub 1 is equal to m times x minus x sub 1. Well, they gave us the coordinate, so there's our x and y value, 1 and 0, so I can put those in here. So I know this is going to be 0 is equal to m times 1 plus b, or I've got y minus 0. Y minus 0 is equal to m times x minus 1. So it looks like I need to solve for a slope. Well, as we wrote over here, the differential equation is the formula for your slope, and now we just have to use our formula and substitute in the coordinate 1, 0 for that, and we'll be able to polish that off. So let's see here. We have dy dx, which is equal to my slope, and we're going to evaluate that at 1, 0. So borrowing it from the equation, or it's right here as well if you prefer, we've got 1/3. My x value is 1, and my y value is 0 minus 2, and that's going to be squared. Okay, so just subbing in those values. All right, so what do we have here? 1 times third is a third, negative 2 squared is 4. Looks like we should be getting 4/3 for our value. So we're going to take that 4/3 and we're going to put that in there. But we're also going to put it in right here, and we'll solve for b. So this one, since this one's pretty nice, we can drop off that 0. We get y is equal to 4/3 times the quantity x minus 1. And if you went point slope, you're done. If we went y equals mx plus b, we got 4/3 here. I think we can sneak that in right there. We'll do 0 is equal to 4/3 times 1 is 4/3 plus b. Subtract that over, and I think you can see, we'll put this off to the side here, that b must equal negative 4/3 when you subtract that over. So my slope-intercept form would be y is equal to, my slope again of 4/3, x minus 4/3 for my y-intercept. And again, both formats are fine. AP doesn't care. Okay, but then the second part of the question says to use either one of these to estimate what is the value approximately of the function at 0.7. So what they want you to do is do f of 0.7. And 0.7 is 7/10, and you have fractions, and so it doesn't matter which one you do here. This one's set up pretty nicely with point slope. If we put 0.7 in there, we would have, in fact, we'll do it right here. We have 4/3 times 0.7 minus 1. Well, 0.7 minus 1, you're going to get negative 0.3, which would be 3/10. And so we'll do it this way. We would get 4/3 times negative 0.3. And 0.3 is 3/10. So I'm going to say 4/3 times a negative 3/10. Cross cancel with the 3's, so my answer is going to be negative. And I would have negative 4/10, which would reduce to negative 2/5, or you could leave it as the decimal negative 0.4. Either one of these are acceptable. Okay, so that was our approximation of f of 0.7. And just to make it real clean, we could say, I think we'll have enough room over here, we will say f of 0.7 is approximately negative 0.4. Okay. So again, the first part of part B being find the equation, the second part was estimate 0.7, which we did there and got negative 4/10. Okay. Then the bulk of the question is part C, which is actually solving this differential. So Here's where all the points, most of the points are, and if you're good at solving differential equations, you should look forward to this one. And out of the 9 points possible, we had 2 points for A, 2 points for B, and here's 5 points for C if you can solve this differential. So let's see how we do. So dy dx is equal to 1/3 x times the quantity y minus 2 squared. Okay. So step 1, let's separate our variables. So I'm going to bring y minus 2 squared over and bring over dx. So I wind up with dy over y minus 2 squared is equal to 1/3 x dx. Okay, now I'm going to integrate both sides. So we've got the integral of dy over y minus 2 squared is equal to the integral of 1/3 x dx. Pretty friendly integral on the right side, so let's go ahead and do that one. Add 1 to our exponent, divide by our new exponent. So we're going to have x squared over 6 plus c over here. That one's pretty nice. And then over here, if you happen to recognize, you're going to want to do a little u sub here. But you might recognize that du is going to equal dx, but I'm going to write one extra step here so we don't lose anybody. So this is actually going to move this to the numerator. So really this is y minus 2 to the negative 2 dy. Okay. And again, technically if you do u sub, which I know a lot of you don't need to, but I'm going to put it here so we don't lose anybody. I'm going to put my u sub to the left here. And if I said, well, I'm going to let u equal y minus 2. And that would mean du would equal to dy, which is why you can probably do this in your head. But I'm going to write it like this. U to the negative 2 dy is equal to x squared over 6 plus c. So now we have u to the negative 2. I'm going to replace my dy with du here, and just so we can do it all in one step. Okay, so now I have a u-based integral. Add 1 to your exponent, divide by your new exponent. Make sure you don't do some silly little natural logarithm things here. This is just a straightforward one. Add 1 to your exponent, divide by your new exponent. So adding 1 to negative 2 equals negative 1. So this winds up equaling u to the negative 1 divided by negative 1. And then, again, I haven't done anything else over here. But now we have to put u back in because u is y minus 2. So I'm going to bring u to the denominator and bring my negative 1 to the numerator. So this is going to be negative 1 over y minus 2 is equal to x squared over 6 plus c. Okay, now for some reason sometimes just this is just confusing for some, but just take your time and look at it. It should make sense to you. This is where we're at right now. So we have to solve this entire thing for y. So the next thing I'm going to do is solve for c while I'm here. And so at this point right here, I know the coordinate here we were given is 1, 0. So let's go ahead and put that in and see what happens. And so I'm going to get negative 1 over 0 minus 2 is negative 2 is equal to 1/6 plus c. So this becomes a half. So this is a positive 1/2, and I'm going to subtract 1/6 to get my c value. And if I just get a common denominator here, I'll get 3/6 minus 1/6, and that is equal to 2/6, and that is equal to 1/3, and that must be my c value. So my c value is 1/3, and I'm going to go and return that value to there and continue with the question. So I'm just going to draw a line to separate, and I'm going to go back to here. Okay, so I get negative 1 over y minus 2 is equal to x squared over 6 plus 1/3. Okay. Now the next little part here is nothing but algebra manipulation, which I've discovered can sometimes lose people. So I'm going to go through it very slowly. It's not necessary you do this, but it makes it a lot cleaner to do the problem. Because I have this y minus 2 in the denominator, I'm noticing that this is going to be, if I don't do what I'm going to do next, it's going to be algebra nightmare, fraction nightmare, and probably make a mistake. So what I'm going to do is just clear fractions. And by doing that, I'm going to look at the entire problem and I'm going to say, man, this thing would be a lot easier if I just multiply the whole thing by 6. So I'm going to distribute a 6 into each term. And what that turns into is negative 6 over y minus 2 is equal to x squared plus 2. And that's a whole lot nicer to deal with. So now I'm going to cross multiply, if you will. I'm going to bring the y minus 2 up, the x squared plus 2 down. And so this turns into negative 6 over x squared plus 2 is equal to y minus 2. And the final step is just to add the 2 over. And so we get negative 6 over x squared plus 2, and then plus 2 is equal to y. Or I like to write y first, so I'm just going to say y is equal to 2 plus negative 6 over x squared plus 2. Clean that little numerator up, negative 6, there we go. And you could put the minus here and leave that plus, whichever you'd like, doesn't matter. Okay, and that is the final answer there. So again, 2 points for A, 2 points for B, but then 5 points for solving this differential, okay, and then putting in your coordinate to get your correct C value, and then cleaning this up and isolating for Y. And just so you know, for point allocation, you get a point just for separating your variables, a point for each antiderivative, or each integral, 1 point for solving for C, and then 1 point for solving for Y. So they're pretty gracious here, just going through each step, giving you some credit here. So even if you make an error in one spot, you're not going to lose all your points. Okay, so there is 2018 question number 6, differential equation. Thanks for watching. See you next time.